Hello students. So this is our last class of group 15 elements. So we have already taught mainly 3 classes for the group 15 elements. If I want to summarize this portion, in our first class we have mainly taught about the group 15 elements, their physical state, means which one is solid, which one is gas, like that. How many metals are there, how many non-metals and how many metalloids are there. How can we get the group 15 elements from the Earth's crust? These things we have discussed. Next, the order of the ionization energy, electronegativity, melting point, boiling point. This many things we have already discussed. And after that we have also discussed about the different allotropic forms. Like in case of phosphorus, it can be exists as the white phosphorus, red phosphorus, alpha phosphorus, beta phosphorus, gamma phosphorus, and how can we interchange between them. So these things we have read in our first class. Then the different oxidation state of nitrogen, like it can be spread from -3 to +5 oxidation steps, and what are the compounds related to it. We have already discussed these things. And in case of the other congeners of group 15 elements like phosphorus, arsenic, antimony, bismuth, what are the oxidation states of them? These things we have taught. So nitrogen, in case of the nitrogen, it cannot form the p-pi-d-pi bond due to the absence of the d orbital, but phosphorus, it can form the d-pi-p-pi or d-pi-d-pi bond, and these things can also be happened in case of the arsenic, but antimony and bismuth, mainly they are forming the single bond or the sigma bond. So these things also we have taught in our last classes. So then we have synthesized the nitrogen, and then the main thing, that is the hydrides of the group 15 elements. हम लोग देखे हैं कि जो हाइड्राइड जो होता है ग्रुप 15 एलिमेंट्स में, दैट इज द अमोनियम, फॉस्फीन, आर्सेन, स्टीबाइन, बिस्मुथाइन, और इसका स्टेबिलिटी ऑर्डर, इसका रिड्यूसिंग कैरेक्टर क्या होगा, हाउ कैन यू सिंथेसाइज दीज हाइड्राइड्स, ये सब के बारे में हम लोग डिस्कस किए. हम लोग के पास सबसे इम्पोर्टेंट जो है दैट इज अमोनिया एंड फॉस्फीन, तो इससे ही मेनली हम लोगों को सबसे ज़्यादा जानकारी भी मिलता है. तो अमोनिया को हम लोग कैसे सिंथेसाइज कर सकते हैं, इसका प्रॉपर्टीज़ क्या है, इसका कुछ डिफरेंट रिएक्शन के बारे में भी हम लोग डिस्कस किए. इसके अंदर नाइट्रोलिन इज़ वन ऑफ द मोस्ट इम्पॉर्टेंट थिंग. और उसके बाद हम लोग फॉस्फीन के बारे में जाने, दैट इज़ द अदर हाइड्राइड्स ऑफ ग्रुप 15 एलिमेंट्स, दैट इज़ द फॉस्फीन. तो फॉस्फीन को हम लोग कैसे सिंथेसाइज कर सकते हैं, और इसमें अनदर थिंग दैट इज़ द होम्स सिग्नल, इसके बारे में भी हम लोग बताएं. तो ये हम लोग का हाइड्राइड हो गया. हाइड्राइड में मेनली हम लोग एमोनिया और फॉस्फीन, ये दोनों में कंसंट्रेट किए. नेक्स्ट हम लोग का हैलाइड में आते हैं. हैलाइड में हम लोग देखें कि द ग्रुप 15 हैलाइड्स मेनली दे आर ट्राइहैलाइड्स और पेंटाहैलाइड्स, like NCl3, PCl3, HCl3, Cl3, BiCl3, or PCl5, HCl5, SbCl5, like that. So mainly trihalides and pentahalides. How can we synthesize them? So these things we have already taught. How are the like PCl5, it can be situated like PCl4 plus or PCl6 minus, like that. Then the few synthetic procedure for the PCl3 and PCl5, and a few of the reactions. So these things are there in case of the halides of group 15 elements. Next, after hydride and halide, the next thing, that is the oxides of the group 15 elements. In case of the nitrogen, which is the first congener of the group 15 element, what are the oxides are there in case of the nitrogen? तो हम लोग देखे हैं कि नाइट्रोजन का ऑक्साइड्स मेनली N2O होता है, दैट इज द डाइनाइट्रोजन ऑक्साइड, और nitrous oxide, in which the oxidation number of nitrogen, that is +1. So how can we synthesize that nitrous oxide? That is also known as the laughing gas. And what are the applications of that laughing gas? These things we have already seen. Next we had seen the nitric oxide, that is the NO, that is also known as the nitrogen monoxide, and how can we synthesize that nitric oxide, and what are the reactions we had seen in our last class, these things. Okay. Next, the nitrogen sp oxide or the nitrogen trioxide, that is the N2O3, where the oxidation number of nitrogen, that is +3. How can we synthesize them? What are the properties of N2O3? These things we had seen. Next was the NO2, that is the nitrogen dioxide. How can you synthesize the nitrogen dioxide, and what are the reactions associated with it? We had seen these things. And finally the oxides of nitrogen, that is the N2O5, that is nitrogen pentoxide, and which is actually white solid and melting point is 35 degrees centigrade and acidic in nature. And how can you synthesize that N2O5, that is actually known as the anhydride of the HNO3. So if I will eliminate the water from the nitric acid, then we can get the N2O5. Okay, so this is all about the oxides of the nitrogen. Then the oxides of the phosphorus we have seen. Mainly 3 oxides are there in case of the phosphorus. One is the P2O3, another one is the P2O4, and the next one is the P2O5. Out of them, mainly P2O3 and P2O5, that is very, very important because they exist as the dimer and their structure, and the structure is very, very important for your exam also. So these two structures are very important. That is the structure of the P4O6 and the structure of the P4O10. You have to remember these two structures. After that the oxyacids. What are the oxyacids in case of the group 15 elements? First of all, we had discussed about the oxyacids of the nitrogen. The first one is the hyponitrous acid, then the nitrous acid, which is little bit unstable, and after that the nitric acid, and that nitric acid is known as the aquafortis, which is very, very important. Everybody we know about the nitric acid. And how can you synthesize the nitric acid? Mainly the Ostwald process is very important to synthesize the nitric acid. After that, we had seen the different types of reactions of the nitric acid, like it can be reacted with the copper at different condition. It can be reacted with the phosphorus, and the reactions of nitric acid with carbon, that is also there. So from our today's class, mainly I will discuss after that is the reaction of zinc with the nitric acid. So if I will use the concentrated nitric acid and I will just add dropwise that nitric acid over the zinc metal, then we can get the NO2 or the nitrogen dioxide gas. If I will dilute the concentration of the nitric acid, that is from concentrated to 30% concentration, then we will get the NO, that is the nitric oxide gas. And again, if I will dilute the concentration of nitric acid to 20%, then we can get the nitrous oxide, that is the laughing gas. After that, again, if I will dilute the concentration to 10%, in that case we can observe only the nitrogen gas. Okay, so 4 different gases we can get if I will use the different concentrations of the nitric acid, and these nitric acids if I will react with zinc. After that, the reaction of iodine with the HNO3. Iodine is there. If I will add the nitric acid into it, then again we will get the NO2 gas. And if the sulfur is there, that is suppose the S8 plus 48 HNO3, that is concentrated HNO3, then we will get the H2SO4 plus NO2 plus water. So the last reaction is very important because here the sulfur is there and the nitric acid is there at the left hand side, and in the right hand side mainly the sulfuric acid is formed. Okay, so that is one of the reaction where at the left hand side a strong acid is there, and at the right hand side another very well known strong acid is there. Okay. Next is the brown ring test. What is that? That is the test for the nitrate salt. Suppose I have the nitrate salt and we are adding the ferrous sulfate and concentrated H2SO4 into the nitrate salt, then finally we will get a brown ring in the टेस्ट ट्यूब। तो यहाँ पर मेनली क्या होता है, सपोज मेरे पास कोई एक नाइट्रेट सॉल्ट है दैट इज NO3 माइनस, इसके साथ आयरन 2 प्लस दैट इज द फेरस सल्फेट है, तो यहाँ पर Fe2 प्लस लिख रहे हैं और कंसनट्रेटेड H2SO है तो यहाँ पर H प्लस दे रहे हैं। तो अल्टीमेटली आफ्टर द रिएक्शन एज अ इंटरमीडिएट इट विल फॉर्म Fe3 प्लस along with NO. NO means the nitric oxide, and that NO, that nitric oxide again reacts with the FeH2O whole 6 2 plus, and finally it will form FeH2O whole 5 NO2 plus water. So that is known as the penta aqua nitrosoferrous cation. Okay, so that is known as the penta aqua nitrosoferrous 2 plus. So if the sulfate is there, if we are using the FeSO4, that is the ferrous sulfate, then the brown ring that actually forms, that is due to the presence of FeH2O whole 5 NO-SO4, and the name of that means the IUPAC name of that ring, that is penta aqua nitrosoferrous sulfate. सो ये जो कंपाउंड का जो मैं IUPAC नेम जो बताया, जो हम लोग मेनली कोऑर्डिनेशन कंपाउंड IUPAC नेम में भी देखे हैं, दैट इज द मेन कॉम्प्लेक्स फॉर द ब्राउन रिंग टेस्ट. ओके, नेक्स्ट दैट इज द परनाइट्रिक एसिड, दैट इज HNO4. वी हैड shown the structure of that pernitric acid, that is also oxo acids. Next after that we are going to the oxo acids of phosphorus. So that portion is very important. So many questions, मतलब जो तुम लोग का बोर्ड एग्जाम में भी आ सकता है या कोई भी ऑनर्स लेवल का कोई भी एग्जाम, डिग्री एग्जाम में, कॉम्पिटिटिव एग्जाम में, ये पोर्शन बहुत इम्पोर्टेंट है. दैट इज द ऑक्सो एसिड्स ऑफ द phosphorus. Okay, so we are going to start at first the oxo acids of phosphorus with hypophosphorus acid or the phosphenic acid. So what is the formula of the hypophosphorus acid? That is the H3PO2. So that is our hypophosphorus acid. Okay, that is our H3PO2. And the structure of the hypophosphorus acid, that is this one. So in that structure we can observe that only one OH group is there. That's why the hypophosphorus acid, that is H3PO2, that is monobasic in nature. That's why that is monobasic in nature. तो ये सब चीज़ क्या होता है, ये सब चीज़ MCQ में कभी आ जाता है. तो H3PO2 जो है that is hypophosphorus acid, that is monobasic in nature. तो इसको हम लोग सिंथेसाइज कैसे कर सकते हैं, ये रिएक्शन हम लोग पहले भी देख चुके हैं. दैट इज P4 phosphorus plus NOH plus water, it will form phosphine along with NH2PO2. और इस NH2PO2 में if I will add the aqueous HCl, then we can get the hypophosphorus acid. Okay, and that hypophosphorus acid and its salt, that is the powerful reducing agent. That is the powerful reducing agent. Okay. And the next oxo acids of phosphorus, that is the orthophosphorus. That is the orthophosphorus or the phosphonic acid. That is orthophosphorus or phosphonic acid. तो ये जो orthophosphorus acid जो हम लोग बोल रहे हैं, orthophosphorus acid, इसका फॉर्मूला है H3PO3. ओके, सो दैट इज नोन एज द phosphorus acid भी इसको कोई बोलता है, और orthophosphorus acid भी बोलते हैं, और phosphonic acid भी बोलते हैं. तो दैट इज द H3PO3. तो ये जो H3PO3 जो है, दैट इज द स्ट्रक्चर, दैट इज द स्ट्रक्चर ऑफ द H3PO3. और यहाँ पर देखो दो OH ग्रुप है, ये जो स्ट्रक्चर हम लोग ड्रॉ किए हैं, एंड फॉर दैट रीजन द orthophosphorus acid और H3PO3 दैट इज डाई बेसिक इन नेचर. तो इसको हम लोग सिंथेसाइज कैसे कर सकते हैं. सपोज आई हैव द P2O3, दैट इज phosphorus trioxide or P4O6, and when it will react with water, it will form the H3PO3. And if I will hit that H3PO3, that is little bit unstable, and it will form ultimate phosphine along with the H2PO4, that is also known as the phosphoric or the orthophosphoric acid. The next oxo acid, that is the pyrophosphorus acid, that is our pyrophosphorus acid, and the structure of that pyrophosphorus acid is the formula, that is the H4P2O5, and that is the structure of that H4 P2O5. So from that structure of the pyrophosphorus acid, we can say that the 4 wedge groups are there in case of the pyrophosphorus acid, and for that reason the pyrophosphorus acid, that is tetra-basic in nature. So for the synthetic procedure, if I have the H3PO3, that is the orthophosphorus acid, and when it will react with PCl3 and water, it will give the pyrophosphorus acid, that is our H4P2O5. Okay, the next one that is the hypophosphoric acid. Hypophosphoric acid. So what is the structure? What is the formula? The formula of that hypophosphoric acid, that is H4P2O6, and the oxidation number of phosphorus, that is +4. So the structure that is the hypophosphoric acid, that is here, and from that structure we can see that the 4 OH groups are there. So obviously the hypophosphoric acid, that is tetra-basic in nature. So how can you synthesize it? We can synthesize it if I will react with the red phosphorus with NaOH, then we can get the hypophosphoric acid. Okay, then we can get the hypophosphoric acid. Next oxo acids of phosphorus, that is also very important, that is the orthophosphoric acid, or that is also known as the only phosphoric acid, glacial phosphoric acid, phosphoric acid हम लोग बोलते हैं इसको, और इसको हम लोग कैसे लिखते हैं? that is H3PO4, that is very well known, क्योंकि हम लोग जानते हैं H3PO3 that is phosphorus acid or orthophosphorus acid, and H3PO4 that is phosphoric acid or orthophosphoric acid. These two acids are very important, and these acids are also the oxo acids of the phosphorus. तो ये जो H3PO4 है, इसमें इसका oxidation number is +5, phosphorus oxidation number is +5, and the structure of the orthophosphoric acid or the phosphoric acid, which is here. Okay, so that is the structure of the orthophosphoric acid, and from that structure it is very easy that to know that that is our tri-basic in nature. So orthophosphoric acid, that is actually tri-basic in nature because the 3 wedge groups are there, that's why. So how can I synthesize it? Suppose I have P4O10, and that when the P4O10 reacts with water, it will form the H3PO4, and it is syrupy solid due to presence of the hydrogen bonding. So if I will hit that orthophosphoric acid or phosphoric acid, first of all it will form H4P2O7, which is known as the pyrophosphonic acid. Okay, which is known as the pyrophosphoric acid, and if I will again hit it, then it will form HPO3. So if I will hit the orthophosphoric acid, it will form the pyrophosphoric acid, and then it will form HPO3, that is also known as the metaphosphoric acid. So till now, in case of the oxo acids of phosphorus, we have discussed the structure, the formula, the oxidation number of the phosphorus, and the synthesis of these oxo acids of phosphorus. So many oxo acids of phosphorus जो है हम लोग देखे हैं. First of all जो देखे हैं, that is the hypophosphorus or phosphenic acid, next orthophosphorus, next pyrophosphorus, next hypophosphoric acid, next orthophosphoric acid, and now the pyrophosphoric acid. Okay, now the pyrophosphoric acid, and the structure is that is H4P2O7, and the formula is that is the H4P2O7, and the oxidation number of phosphorus, that is +5 in case of the pyrophosphoric acid, and that is the structure of the pyrophosphoric acid. So from that structure we can easily see that the number of OH groups in the pyrophosphoric acid, that is +4. So obviously that is also tetra-basic in nature. So the application of that is the Ca2H2P2O7, that is the calcium salt of the pyrophosphoric acid, that is used in the toothpaste. Again, the Na2H2P2O7, that is the sodium salt of the pyrophosphoric acid, that is used in the making bread. Okay, so these are the few applications of the pyrophosphoric acid. Next one, that is the metaphosphoric acid. Metaphosphoric acid is usually HPO3 whole N. It can be 1, it can be 2, it can be 3. So HPO3 whole N, and in which the oxidation number of phosphorus, that is class 5. So that is our metaphosphoric acid. And so if I will tell about the HPO3 whole 3, so that is the structure, that is actually cyclic structure of the metaphosphoric acid, and it can be linear structures also. Next, oxo acids of phosphorus, that is the peroxy phosphoric acid, that is the peroxy phosphoric acid, and that is our H3PO5, and that is the structure, that is also known as the peroxy phosphoric acid, that is H3PO4. H3PO4 में और एक ऑक्सीजन उसमें लगा दो, इसीलिए उसको हम लोग पेरोक्सी फॉस्फोरिक एसिड बोलते हैं. पेरोक्सी का मतलब हम लोग जानते हैं, ओ बॉन्ड ओ को हम लोग पेरोक्सी बोलते हैं. वैसे हाइड्रोजन पेरोक्साइड, हाइड्रोजन पेरोक्साइड में भी ओ बॉन्ड ओ रहता है. यहाँ पर भी देखो, ये जो पेरोक्सी फॉस्फोरिक एसिड है, इसीलिए यहाँ पर भी ओ बॉन्ड ओ हम लोग यहाँ पर दिखा रहे हैं. द एसिड्स containing pH bond means the pH bond, where the pH bonds are there. You can see in these structures we had seen the pH bond here. In case of the phosphenic acid or H3PO2, the 2 pH bonds are there. Okay, the 2 pH bonds are there. In case of the H3PO3, only 1 pH bond is there. Only 1 pH bond is there. So in such a way, the acids containing pH bond have strong reducing properties. Okay, जितना नंबर ऑफ pH बॉन्ड रहेगा उतना ज़्यादा उसका रिड्यूसिंग प्रॉपर्टी होगा. इसीलिए H3PO2 इज अ पावरफुल रिड्यूसिंग एजेंट. इसीलिए हम लोग H3PO2 जो है दैट इज पावरफुल रिड्यूसिंग एजेंट, मतलब दूसरे को आसानी से रिड्यूस कर सकता है और खुद ऑक्सीडाइज हो जाता है. ठीक है, तो ये कैसे दूसरे को रिड्यूस कर सकता है, क्योंकि ये जो pH बॉन्ड है, ये जो pH बॉन्ड दैट इज नॉट वेरी मच स्टेबल. तो ये जो pH बॉन्ड जहाँ पर भी है, ये pH बॉन्ड ब्रेक कर जाता है और वहाँ से हाइड्रोजन रिमूव हो जाता है, और जो हाइड्रोजन मेनली दूसरे का रिडक्शन में हेल्प करता है. ठीक है, सो यहाँ पर हम लोग एक एग्जाम्पल भी दिखा है. सपोज आई हैव AgNO3 एंड व्हेन दैट AgNO3 रिएक्ट्स विद द H3PO2 along with water, it will form Ag plus HNO3 plus H3PO4. So in that reaction you can see that H3PO2 is oxidized to H3PO4 and AgNO3 is reduced to Ag. That's why H3PO2 यहाँ पर क्या किया, AgNO3 में जो Ag प्लस है उसको Ag जीरो स्टेट में लेके आया, मतलब उसको रिड्यूस किया. That's why H3PO2 is here रिड्यूसिंग एजेंट, और यहाँ पर उसका खुद को ऑक्सीडेशन हुआ है. So after that, the almost the last topic, that is the inorganic rubber. What is the inorganic rubber? Everybody will know about the inorganic benzene. Inorganic benzene, that is the borazine. Okay, B3N3H6. Okay, that is the inorganic benzene. ऐसे ही inorganic रबर भी होता है. इनऑर्गेनिक रबर, अच्छा और एक चीज़ है इनऑर्गेनिक रबर जो हम लोग बोल रहे हैं, तो ये मेनली है क्या, ये मेनली है दैट इज द NpCl2. मतलब NpCl2 में अगर N की जगह पर हम लोग 3 लिखेंगे तो इसको हम लोग बोल सकते हैं हेक्सा क्लोरोफॉस्फाजीन. सो दैट इज द इनऑर्गेनिक रबर. तो phosphagene, hexachlorophosphagene, that is the inorganic rubber. So how can you synthesize it? Suppose I have PCl5, that is phosphorus pentachloride, and when it reacts with ammonium chloride at 60 degrees centigrade in vacuum, it will form NpCl2 whole N plus HCl. N is equal to mainly 3 and 4. When it is 3, then it can be called as the hexachlorophosphagene, and it is used as a precursor of the polydichlorophosphagene, that is the inorganic rubber. Okay, इसलिए इसको हम लोग इनऑर्गेनिक रबर भी बोलते हैं. ऐसे इनऑर्गेनिक ग्राफाइट किसको बोलते हैं, इनऑर्गेनिक ग्राफाइट हम लोग किसको बोलते हैं, बोरॉन नाइट्राइड. हम लोग देखे थे इनऑर्गेनिक ग्राफाइट इज बोरॉन नाइट्राइड, इनऑर्गेनिक बेंजीन इज बोराजीन. ऐसे ही इनऑर्गेनिक रबर क्या है? इनऑर्गेनिक रबर इज हेक्साक्लोरोफॉस्फेजिन, ठीक है, इनऑर्गेनिक रबर इज हेक्साक्लोरोफॉस्फेजिन, दैट इज NpCl2 so that is the structure, that is the structure of NpCl2 और इसको हम लोग इनऑर्गेनिक रबर भी बोलते हैं। नेक्स्ट इज द सुपर फॉस्फेट ऑफ लाइम, सो दैट इज द लास्ट पार्ट। व्हाट इज द सुपर फॉस्फेट ऑफ लाइम? इसको हम लोग कैल्शियम सुपर फॉस्फेट भी बोलते हैं। दैट इज द मिक्सचर ऑफ द कैल्शियम डाइहाइड्रोजन फॉस्फेट, दैट इज CaH2PO4 एंड जिप्सम। जिप्सम इज द कैल्शियम सल्फेट dihydrate. Okay, so that is the CaSO4.2H2O. So the mixture of the calcium dihydrogen phosphate, that is CH2PO4 and the gypsum, this mixture is known as the superphosphate of lime. So how can we prepare the superphosphate of lime? Suppose I have the CO3PO4, that is the calcium phosphate, and when it reacts with the sulfuric acid and water at 100 degrees centigrade for 24 hours, it will form the calcium dihydrogen phosphate, that is CH2PO4 plus 2 molecules of gypsum, that is CaSO4.2H2O. Okay, so it is a good phosphate fertilizer. So superphosphate of lime, that is a very well known and very useful phosphate fertilizer. Calcium sulfate present in it, which possess insoluble waste product. To avoid it, it is changed into triple phosphate, which is soluble in water. तो यहाँ पर हम लोग सुपर फॉस्फेट ऑफ लाइम के बारे में डिस्कस किए हैं। और एक भी चीज़ होता है जिसको हम लोग ट्रिपल फॉस्फेट के नाम से जानते हैं। उसमें क्या होता है, ये जो सुपर फॉस्फेट ऑफ लाइम हो रहा है, इसमें कभी कभी कैल्शियम सल्फेट रहता है। तो उस कैल्शियम सल्फेट तो हम लोग जानते हैं कि दैट इज इनसॉल्युबल इन वाटर। तो ये चीज़ को अगर हटाना है तो उसके लिए हम लोग ट्रिपल फॉस्फेट भी कभी कभी यूज़ करते हैं, विच इज़ मेनली सॉल्युबल इन वाटर। सो दैट सुपर फॉस्फेट ऑफ लाइम जो हम लोग बात कर रहे हैं, दैट इज़ वेरी गुड फॉस्फेट फर्टिलाइजर। ओके, सो दैट इज़ ऑल अबाउट अवर ग्रुप 15। तो ये ग्रुप 15 में हम लोग मेनली इसका रिएक्शंस देखे हैं, इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन, इसका फिजिकल स्टेट क्या क्या होता है। उसके बाद हम लोग हाइड्राइड्स के बारे में डिस्कस किया, हाइड्राइड्स ऑफ द ग्रुप 15। उसके बाद हैलाइड्स ऑफ ग्रुप 15, और उसके बाद ऑक्साइड्स ऑफ ग्रुप 15, एंड फाइनली द ऑक्सो एसिड्स ऑफ ग्रुप 15, एंड एट लास्ट हम लोग इनऑर्गेनिक रबर और सुपर फॉस्फेट ऑफ लाइम के बारे में भी डिस्कस किया। ठीक है, तो ये 4 क्लास टोटल मिला के हम लोगों का ग्रुप 15 पोर्शन कंप्लीट हो गया। इसको अच्छे से रीड करो। ओके, थैंक यू।